Hey everyone, we're doing Unit 2, Lesson 3, Function Composition, Common Core Algebra 2. We're doing the non-Regents version. If you don't understand what I'm saying, just scan that QR code, and you can listen to the genius who made these pages. Okay, let's go. Since functions convert the value of an input into the value of an output, we can then think that this output can then be used as an input for a second function. This process is known as composition of functions. In other words, combining the action or rules of two functions. Let me show you a very basic function. F of x equals x. Whatever you put in comes out. Then composition of functions, g of x equals 2 times f of x. What does that look like as an equation? That might look like as an equation as y equals 2x. If you don't understand, make sure you ask me in class. Exercise 1. A circular garden with a radius of 15 feet is to be covered with topsoil at a cost of $1.25 per square foot of garden space. Determine the area of this garden to the nearest square foot. Nearest, so round. Let me see, area of a circle. Area equals pi times radius squared. Radius of 15 feet, so we don't have to cut it in half if it's the diameter. Area equals pi times 15 squared. That's 225 pi square feet. But it says the nearest foot, so I'll grab my calculator and round the answer. It's 706.85, but it says it's the nearest square foot, so it's 707 square feet. Notice that you can write square feet like this, or you can write square feet like that. Using your answer from A, we've got to use that answer, 707 square feet, not 707.85 square feet. Calculate the cost of covering the topsoil. So that is 707 times $1.25. $883.75. What we just did here in this exercise, we see that the output of one function, the 707 square feet, is used as the input for the other function to find the cost. This can be generalized in a generic formula like this. The input then becomes the input to G. And we have our final answer. There are two notations that are used to indicate composition of functions, okay? Fog, and then there's this. These will be introduced in the next few exercises, both with equations and with graphs. Okay. How do you do this? How do you do this, Mr. Bryce? How do you do this? Inside, out. Okay, you do the inside and you work outwards. It's the nearest one. 1 is nearest to G. So you plug 1 into G. So you find f of, here's G's function, 2x plus 3. F of 2 times 1 plus 3. 2 times 1 is 2, plus 3 is 5. You find f of 5. Function value at 5. Evaluate the function f at 5. Running out of room here. So we do x squared minus 5 happens to be 20. I just plugged it into that equation right there. Okay. Now, we plug this not into G, we plug it into F. So G evaluated at 2 squared minus 5. The 2, got it? That's negative 1. G of negative 1. Plug negative 1 into G. 2 times negative 1 plus 3 is positive 1. Evaluate the function g at 0. 2 times 0 plus 3. Then we're going to evaluate g again. G of 3. 2 times 0 is 0, plus 3 is 3. So now g of 3, 2 times 3 plus 3 is 9. So g of 0, see how I say that? G of 0 is 9. Fog and Goff. Okay? Again, closest one. F of the function value, and then just have to scroll up because I didn't memorize the function. 2 times negative 2 plus 3. The function value of negative 1. So the function value f at negative 1 is negative 1 squared minus 5 is negative 4. Plug 3 into f. Are you done yet? It's 4. Evaluate the function g at 4. It's 11. Just did the mental arithmetic. We've done a lot. Now we can just function value f at negative 1 is negative 4. So now we have to do the function value at negative 4. Function value f at negative 4 is 9. 11, sorry. See, even when I'm done with the problem, I still have it going through my head. 16 minus 5 is 11. Plenty of time. Let's look at the next page. Now we're going to do a graph. The graphs below are functions. Y equals f of x and y equals g of x. Evaluate each of the following questions based on the two graphs. Okay. You can get a ruler or a pencil or something like that when you're doing this during a test. It says find the function f at 2. This one is f, so I'm going to go to 2, and I see that it is that high, which is 3. So that means this is going to be g of 3. Then I go over to g, and I see where is 3. It is that high. It's 3 high. G of negative 1. Go to g, negative 1. It's that low, which happens to be negative 1. So now I have to find f of negative 1. These are just coincidences. Okay. Now I find f of negative 1, which happens to be right there. That's not negative 1. Go back here. Mistake, Mr. Bryce. Negative 1, negative 2, negative 3, negative 4, negative 5. It's negative 5. I know, I counted that, I did everything, and that's like, gee. Okay, so we go to negative 5. Negative 1, negative 2, negative 3, negative 4, negative 5. Well, it's still a horrible answer, but it's really not that horrible. I'll explain why right now. Okay, we see that it goes over 2 and down 1. So since it only went over 1, it must go down a half. So that is negative 1/2. Let's do D. D says do f of negative 2. The function f, make sure I'm on the right function. Yes, this is the function f of 2. 1, 2. It hits the line right here. It's that high. 1, 2, 3. So now I have to find g of 3. I go over to function g. 0, 1, 2, 3. It's that high right there. And what's that value function? What's the output? 1, 2, 3. So the answer is also 3. And let's do E. We have g of 0. G of 0 is 0. So then we come over to the f function at 0, because the output was 0, and we see that we go up 2. So the answer is 2. How do I want you to show your work? I want you to show something like this. That's the minimum. No, not enough work. On occasion, it's desirable to create a formula for the composition of functions. Okay. What does it mean? Very simple. F of x equals 3x plus 2. F of 2 equals 3 times 2 plus 2. Let's make that a 3. Arg. Because I have a 3 and a 2 in there. F of 5 equals 3 times 5 plus 2. I just don't want to use the same variables so you're all confused. Everywhere I see an x, I put a 5. Everywhere I see an x, I put 5x plus 4. I have a 3. It's not an x. I have an x. I put in parentheses 5x plus 4. I put inside parentheses 5x plus 4. That's that x right there. Then there's a minus. Then there's a 2. There we go. Now, in simplest form, 15x plus 12 minus 2 is 15x plus 10. Let's try this one now. G of f of x. Everywhere I see an x, I put f of x. So 5x plus 4. The 5 is not an x, so I put down the 5. The x is an x, so I put down 3x minus 2. 3x minus 2. Put down 3x minus 2 everywhere I see an x. The plus is not an x, and the 4 is not an x. Distribute, combine like terms. 15x minus 10 plus 4. 15x minus 6. Exercise 5 is just more practice. So since we're 12 minutes into the video, I'm going to call it a day. See you tomorrow.